Now, the first step towards solving a polynomial, either inequality or equation, is to factor. So what I'm going to do is I'm going to look at this equation and try to factor the terms that I possibly can. So you'll see that I'm going to group the first two terms together and the last two terms together. Note that in this question, they've already been put in the order, in the descending order of degrees. Otherwise, I would have to do that myself. So what's common between x cubed and 7x squared is just x squared. So I'm going to write that out as factor out the x squared. If I factor out x squared from x cubed, I'm left with x. And if I factor out x squared from positive 7x squared, I'm left with positive 7. And what can we factor out from negative 4 and negative 28? 28 is a multiple of 4, so I can factor out negative 4. And negative 4 factored out from negative 4x leaves x. And negative 4 factored out from negative 28 leaves positive 7. Since when you multiply negative 4 and positive 7, you get negative 28, and that's less than or equal to 0. There's still more work to be done for the factoring. You'll see that both of these terms have x plus 7 in common. So I'm going to factor that out and make this x plus 7 times x squared minus 4 is less than or equal to 0. Now, to factor x squared minus 4, I'm going to use the formula a squared minus b squared equals a plus b times a minus b. Why does this help? Because you have x squared and 4 can be written as 2 squared. So that's like a squared minus b squared. So I rewrite this as x plus 7, x minus 2 times x plus 2 is less than or equal to 0. Solving an inequality is not as easy as solving an equation, because you can't just say that all three of these terms are less than or equal to 0. When you have a product of three numbers, so you have three numbers, let's call them a times b times c. And all you know is that when you multiply these three numbers, you get a possibly negative number or 0. Now what this means is that you could have many different possibilities. You could have all three of these numbers being less than or equal to 0, or you could have just one of them being negative and the other two being positive, right? Now, that's an insane number of possibilities to check. So what we do instead is we're going to first pick what we call the boundary points. Now, what are the boundary points? The boundary points are precisely the points where this equation would be equal to 0. This expression would be equal to 0. So we pick from each one of them. You'll see that, well, if you were to look at this part, if it was equal to 0, you would have x equals negative 7. If this part were equal to 0, you would have x equals 2. And if this part were equal to 0, you would have x equals negative 2. So those are your boundary points for this equation. Your boundary points are negative 7, 2, and negative 2. Now to make my work easier, I'm going to plot these on a graph. So I have negative 7 here, and I have negative 2 here, and I have positive 2 somewhere here. Now I have to try to find out in which of these intervals does my equation make sense. Now you can write down the original equation, but I prefer to write this version of the equation, x plus 7, x minus 2, x plus 2, since this has easier numbers to deal with. And now what we're going to do is we're going to check. How do we check? What we do is that you'll see that this entire line is broken up into 4 sections, 1, 2, 3, 4. We're going to pick a point from each section. So for example, from this section, I'm going to pick the point negative 8. I'm going to check with that point. So let's see. Negative 8 plus 7 times negative 8 minus 2 times negative 8 plus 2. What does that give me? Negative 8 plus 7 is negative 1 times negative 8 minus 2 is negative 10, and negative 8 plus 2 is negative 6. That gives me negative 60, which is less than or equal to 0. So that works. Okay. Now what this means is that since it worked for this one particular number in this interval, it means that in this entire interval the statement is true. Now let's pick a value in the next interval. From negative 7 to negative 2, I'm going to pick the value negative 4. Okay, now let's see what happens in this interval. So I have negative 4 plus 7 times negative 4 minus 2 times negative 4 plus 2. So I get negative 4 plus 7 is positive 3, negative 4 minus 2 is negative 6, and negative 4 plus 2 is negative 2. So 3 times negative 6 times negative 2 is positive 36. It's not true for this one because what I would need is I would need 36 to be less than or equal to 0, which is obviously false. So that means that in this particular interval, the second interval that I have, my statement is false. Okay, let's move on to the third interval. Now, if there's 0 in an interval, I prefer picking 0 because it's the easiest number to work with. And so in the third interval, 0 plus 7 times 0 minus 2 times 0 plus 2 is 7 times negative 2 times positive 2, which is equal to negative 28, which is less than or equal to 0, is true. So that means that I can mark off the third interval as being a true statement in this interval. And finally, the last interval that I need to look at is the one beyond 2. And over here, I'm going to just pick the closest number, 3. So let's see what happens when x equals 3. I have 3 plus 7 times 3 minus 2 times 3 plus 2, which is 10 times 1 times 5, which is positive 50. Now expecting that to be less than or equal to 0 is preposterous, so that's also false. Okay, so this means that in my last interval also it's false. Okay, so I've been able to single out which the intervals are where it works. This is the interval where it's true, and this is the interval where it's true. Now what about the endpoints, the boundary points negative 7, positive 2, and negative 2? Now note that you have, I know you can't see it very clearly here, but the inequality is less than or equal to 0. Now if x were equal to negative 7, positive 2, or negative 2, then this expression would equal 0, right? If x is negative 7, 2, or negative 2, then this entire expression would equal 0. And so that means that at these points it's true. So what I'm going to have to do is I'm going to have to also include the endpoints, all of these endpoints in my solution. And so that tells me that the solution to this equation is all of these intervals. Okay, so for this interval, I'm going to have to start all the way from negative infinity and come to negative 7. So negative infinity to negative 7. Negative infinity will always have an open parenthesis because you can't include it, and negative 7 is included, so we put a bracket. And the next interval is everything from negative 2 to 2, including negative 2 and 2. So everything from negative 2 to 2 in brackets. And then to show that we're combining them, we put a union sign. And that's the solution to your equation.